All right, so today we're starting off with this equation, f of x equals 0.25x squared. We'll answer a number of different questions on it. And the first one we're going to answer is this. What's it actually asking? It says find m sub pq. That's how we'd read that there, because the p and the q are a subscript, kind of like an exponent. You know, it's written smaller, but it's lower for a subscript. M sub pq. What does m normally stand for? Well, give you a hint. It goes back to y equals mx plus b. M here represents slope. So when we see this written, where we see find m sub pq, what it's actually saying in that notation is it's saying find the slope between points p and q. And you notice we have those labeled on the graph here, point p and point q. But it could also be worth writing out where p and q are on your paper, especially if you don't have this graph drawn already. You just note that p, that's at 2, 1. And q, that's at 6, 9. And so now we know which 2 points we're going between. We can now go ahead and find the slope between those 2 points. So if we're going to find the slope now between those 2 points, remember how we calculate slope. You could remember it as rise over run. That's way back, right? Or you could actually remember the formula y2 minus y1 over x2 minus x1. That tends to be a little bit more complicated than it needs to be. I find that the best way to remember it, and actually one that's going to be super useful here in this class, is remembering it as delta y over delta x. And if you're not familiar with the whole triangle delta thing, we draw a triangle that represents the Greek letter delta, and that always means change in. So delta y means the change in y. So in order to figure out delta y, I look at my 2 points and I say, how much is my y changing when I go up between those 2 points? So how far is it from 1 to 9? 8. So that's going to be 8 over delta x. So that's how far are we going over? It's a change in x. So how far are we going over?
4.
4. And so my slope here is 8 over 4, which of course, yes, I do want to simplify down. 8 fourths equals 2. So there we got it. We got m sub pq. That is the slope between point P and point Q. This line that we see drawn in here, it actually has its own special name. It's actually a name that you are familiar with, but you've always seen it in a different context. And the context you've seen this word used before, yes, it's related to the same idea here, but no, you're not going to be doing it in the same way you did it before. This red line that's drawn here is called the secant line. Because the secant line is a line that crosses through a graph at 2 points, basically. 2 or more points, technically speaking. And so when we deal with secant lines, we're usually looking to see what happens between any 2 points within a given function. All right, next up, we're going to keep practicing this idea. In this case, we're going to now practice it for a q at x equals 4. So again, write down this problem. Notice it's the same f of x, though. I'm not changing which equation you're working with here. And so if I'm going to actually do this, if I'm going to find the slope between points P and Q, I need to actually know where point Q is. And I'm given enough information to know, but I haven't been given everything I will have to know eventually. Because I'm told the x value is 4. Okay, so if the x value is 4, what's the y value? It is 4. So that tells me that Q is up here at 4, 4. Now, if you're sitting there going, how would we know that? Well, we could actually see it on the graph in this case because it's at a nice pretty number, but if all else fails, we can always actually figure out what is f of 4 by plugging it into that original equation. And if you figure out 4 squared is 16, multiply it by 0.25, that gives you 4. So I basically started by plugging that x value that we're given into the original function to see what the y value would be. Now, go ahead and find the slope between those 2 points. All right, so from here, I do want to calculate that slope, and I do want to show that work here just because we're wanting to make sure that everything is solid. To find slope, we always do delta y over delta x. Between those 2 points, delta y, the change in y, 4 minus 1 is 3. Delta x, the change in x, that's going to be 4 minus 2, which is 2. 3 over 2, we can go ahead and leave it like that. That's a good slope, right? We give lots of slopes in fractions. Although you're going to find we're about to go into a lot more decimals with these, because we're going to be getting into some really detail-y numbers. But let's do another practice one before we get there. Please find m sub pq for this q. And of course start by writing down the original problem, and then we'll put the work that goes with it. This is actually the same process, but processing it through using a slightly different notation. But it is a notation you know. So this problem, it says q is at 1 comma f of 1. Well, okay, so I see f of 1 there, so that tells me right away that I'd actually kind of like to know what f of 1 is. So let's do that. F of 1 would equal 0.25 times 1 squared. Okay, so 0.25 times 1 squared is 1, so that'd just give us 0.25. So that's what f of 1 is. F of 1 equals 0.25. Why do we care? When we graph these, f is the same as what? Y. You'll notice how this was written over here. It was 1 comma f of 1. F of 1 just represents the y value. With that notation that they started us off with, basically it was saying x is 1, figure out what y is on your own. Because you have the equations. You can do it on your own. You don't need me to tell you what y is. That's basically what we're being told here. So now that we know that the point is actually 1 comma 0.25, now we can go ahead and find the slope between those 2 points again. So go ahead and finish this problem out. Find m sub pq. Alright, so in order to figure out m sub pq, again we're going to do the change in y over the change in x between them. The change in y in this case, we're going from 0.25 up to 1. So we do 1 minus 0.25, which is going to be 0.75. The change in x, we're going from 1 to 2, so that's 1. And so 0.75 divided by 1 gives me 0.75. Or if you chose to turn that into a fraction, yes, 3/4 would be a lovely answer for that. So up to this point, I've been using this same old equation, this same f of x equals 0.25x squared, to just practice finding the slope between any 2 points. Well, I'm going to switch equations on you. I'm actually going to go to something very similar. Let's take a look here at g of x, which is x squared. No more 0.25. And we are going to actually gather 8 different data points here for all of these different x's and see what the slopes are going through all of those. So let's actually assign those out. Alright, so we got the easy numbers in. And then when we get to 1.5, some of us are getting stuck. So let's actually see the work we do there. First thing is we got to figure out the y coordinate when x is 1.5. So I'm going to go 1.5 squared. So that's just putting it into the equation. Alright, so if I have 1.5 squared, and I actually do that, what is 1.5 squared? Great, so that gives us 2.25. Alright, so then I know for this x value I have a y of 2.25. So when I then go and do my slope, the delta y over the delta x, I'm going between 2.25 and this point at 2.4, so that's a point of 4. So between 2.25 and 4, that is 1.75. Over the change in x, well, I'm going between 1.5 and 2, because remember my x was 1.5 and this x over here is 2. which means it's going to be over 0.5. And now we're into that calculator work more. So if I do 1.75 divided by 0.5, what does that give us? 3.5. All right, so having figured out those values for our slopes between P and all those various Q values, it gives us a lot of different slopes. And notice those slopes, so like between 0 and 2. Our line was looking like that for our secant. Between 1 and 2, it got a little steeper. And it keeps getting steeper as we go to the right here because the graph is getting steeper. Okay. But now, based on this data, there's actually something more we can figure out. Because you'll notice I kind of skipped something in the middle. Did it jump out to you as odd? For some of you, maybe yes, some of you, maybe no. Why did we not do it for x equals 2?
You'd be dividing by 0.
That's one way to look at it. Yeah, we'd be dividing by 0. Because if x is 2, isn't that exactly the same as the point we're already working with? That'd be like saying, what is the slope between the 0.24 and the 0.24? How can it be between them? It's the same thing. It doesn't make sense, right? We cannot go between itself. And so that's why we don't do 2 here. There'd be nothing going on. All right. And yet, that value at 2 is actually the most important one. That's actually what we're trying to work toward. We can now use that to figure out m sub p. Notice it's not m sub pq. M sub p here, that would mean the slope at p. It's no longer the slope between p and q, it's now just the slope at p. In other words, if I was going to draw in a line just touching the graph here at p, what would its slope be? That's what it's asking. Now, what's it look like that would be? I mean, because 2 would be right here, so what's it look like the slope would be based on the data around it? It looks like it would be 4, yeah. And in fact, as we get into it and if we got closer and closer and closer, we would find that it actually is at 4, and this line also has a special name. The line between 2 points on a graph is called the what line? Secant. Yep, secant line. This one, it's another familiar trig name. This is the tangent. The tangent to a curve, just like the tangent of a circle, it touches it at one place. Exactly one place. And so, if we're looking for the slope at P, we are trying to figure out the slope of the tangent line at P, which in this case was 4. Yeah, the question came up. You notice in this case our slope was 4. Our y value at P was at 4. Is that actually always going to be the case? No. Pure coincidence here. So this bit of a brain bender, and yes, if it's still bending your brain, that's okay, is getting us just kind of used to the idea of tangent line. I use g of x equals x squared here as our example, just to get familiar with the tangent line and make some of these calculations easier. But I now want to take one step back to the problem we were working with before. So back here on f of x, we've done some various calculations. We found a couple of the secant slopes here. But right now we want to figure out how we could figure out the slope just at P. So in other words, the tangent line at P for this particular equation. How might you do it? Take a moment and just think through a strategy. How would you find the slope of the tangent through P? All right, so what are some strategies we could use to actually find the slope at P? Yeah, so one method goes back to what we did when we were dealing with g of x equals x squared. Remember when we made that table, the most useful values were the ones that were getting really close to point P. Well, in this case, you could do the same thing. So like in this case, the x value that we are working with is here at 2. So you might try, for instance, x equals 1.9 and x equals 2.1. And you could find those two slopes and see how that might help you. Or you could even go crazier. You could go to like 1.99 or 2.01, and you could get really, really close, and you could do calculations that way. So that's one way you could do it. The other method that a lot of people aren't thinking of, probably because we've been dealing with so much complex stuff here, is why not draw it in and estimate what it looks like. What's it look like that slope is that's going through P?
About 1/2.
And let's hear. It looks like it's going. Looks to me like it's about 1. And actually, if you do this over here, you're going to come up with the same thing. You're going to end up with numbers that are really close to 1. And so, with that idea, I'm just going to go ahead and go forward with that idea. Let's say that the slope is 1. Write the equation of the tangent line at P now. Now this brings you back a little ways, right? You have to remember, how do we write the equation of the line? Well, again, you could kind of draw in the line and see, okay, I think it's crossing the y-axis about here or there or wherever. But there's actually an algebraic way you can do it, which I think we could use a refresher on. Because we're trying to plug into y equals mx plus b. And what's m in this problem? 1. So that's just 1x, which is x. So I know I'm going to have the equation y equals x plus b. And I just now need to figure out what b is. Well, I know point P over here. Point P is at 2, 1. So y is 1, x is 2. I miswrote that here. Just change that. How would I solve that for b? Subtract 2. And so b equals a -1. All right, and so with this one, our equation, just y equals x minus 1. That gives us the equation of our tangent line through point P there.